Hello students, welcome back. Now this video onward we will discuss the further concept of circle. So why to wait? Let's start. Now student, let's solve this sum. Now AB is tangent to the circle at point B. AD is secant which intersect the circle at point C and D. OE is given perpendicular to DC. Apart from this, AB is given 12, AC is given 8. You are asked to find AD, DC and DE. Let's start. Now first of all, you can apply the property of intersecting tangent and secant. So in the first point, I'll apply this property. So your AB square is equals to AC into AD. So it will be theorem of intersecting tangent and secant or property of intersecting tangent and secant. Now AB is 12. AC is 8. So you will get the value of AD. So your AD will be 12 into 12 upon 8. 4 2s are, 3s are, 2 1s are, 2 6s are, 6 3s are, 18. So you got your first distance. Now for the second one, your AD is addition of AC and CD. Or DC also you can write. AD is 18. You got it now only in the first part. AC is 8. Instead of CD, I can write DC also. So your DC is 18 minus 8, that is 10. You got second distance also. Now OE is given perpendicular to the chord DC. So your OE is perpendicular to your chord DC. That we have not taken. It's given. So therefore, E is midpoint of DC. Last year in the 9th standard you have done chord theorem. You know what is chord theorem? Perpendicular drawn from the center to the chord bisects the chord. O is perpendicular to the chord from the center O. So it bisects the chord. So E will be the midpoint of DC. Therefore, your DE will be half of DC. Now only in the second point you have calculated DC. So that is 10. When you reduce, your DE will be 5. So in this way you got the third distance also. Now student, let's solve the sum. Now here both the secants intersect outside the circle. So you can apply the property of theorem of external division of chords. External intersection also. Now PQ is given 6. QR is given 10. PS is given 8. And you are asked to find out TS. Let's solve this sum. Now in the beginning of the video I discussed you have to start all the distance with P. So your PS into PT will be equals to PQ into PR. What reason you will write? Theorem of external division of chords or secants. Now after substituting values, you will get 8 into PT equal to PQ into PR is this full. So 6 plus 10, it will be 16. So your PT will be 6 into 16 upon 8. 8 1s are, 8 2s are, 2 6 are 12. So your PT is 12. But you are asked to find TS. When you look at the figure, PT is PS plus TS. You got your PT as 12. PS is 8. So you can easily get the value of TS. So your TS will be 12 minus 8, that is 4. Now student, in this given figure, EF is the diameter of the circle. Why? Because H center is there on the EF itself. DF is tangent at point F. DE is the secant. Radius is given R and you are asked to prove that DE into GE is 4R square. Now, very first thing, what we can do, your EF is diameter. Okay. So, your EF will be twice of radius. Because this side also radius is R. So, your full EF is 2R. Now, in the second part, I join GF. So, let's join the GF. Now, both the arcs EGF and EF, they are semi-arc because EF is the diameter. So, your angle EGF will be half of 180 degree. So, it will be 90 degree. Why 180? Because it is an semi-arc. So, the reason will be inscribed in semi-arc. Same way, now DF is tangent to the circle. This already we have proved 90. This is also perpendicular. Your DF is perpendicular to EF because you know tangent theorem. Line joining center and tangent point is perpendicular to the tangent. So your angle EFD is also 90 degree. Understood, students? Now I want to show that this small triangle and larger triangle, they are similar. Okay. So why? Because see, one angle already I proved that it is perpendicular 90 degree. This is a common angle in smaller as well as larger. So in triangle DEF and triangle sequence should be proper DEF. So it will be FGE. You just see DEF. D without marking, E then 90 degree. So in the smaller triangle, it will be FEG. Sequence should be in a proper way. So I can write that angle DFE is congruent to angle FGE. Why they are congruent? Each of 90 degree. Okay. Now second angle I require for similarity. So I am taking DEF is congruent to GEF. They are common angle. So my triangle DEF is similar to triangle FGE. by AA test of similarity. You know that once the triangles are similar, their ratio of corresponding side is same. This is my fourth point. So in my fifth point, what I can write, students? DE upon FE is equals to EF upon EG, which in turn will be equal to DF upon FG. Reason you know, they are the corresponding sides of similar triangle. Now if I cross multiply first two sides, EF into EF, EF or FE, one and the same thing. So it will be EF square equal to DE into EG. Now in the first point I shown that EF is a diameter and diameter is equals to twice of the radius. So instead of this we can put 2r that I have taken from the first equation. Now DE. So here it is DE. By mistake I have written DG. So DE I am keeping as it is. This I can write as GE. So your DE into GE will be, you have to take square of this. Square of 2 is 4. Then it is 4 square. This only is asked to prove, students. Thanks for watching this video, students. Hope you have understood whatever I explained in this video. Now, if you have any doubt, you can comment or mail. If you like the video, share and subscribe. Thank you.